Let's have a look at the substitution method for simultaneous equation. Substitution means replacing one thing with another. In this case, we're going to replace the y in this second equation with what the y equals from the first equation. The best way to set this up is to write out your two equations. And then I'm going to label them equation 1 and equation 2 so that I can explain my mathematical thinking and allow other people to follow my working out. So what I'm going to do is I'm going to substitute equation 1 into equation 2. So wherever I see a y in equation 2, I'm going to write what equation 1 tells me that y equals. So I have 2x plus 3. Now instead of writing y, I'm going to write the y value from equation 1 equals 19. Now I'm going to expand the brackets and group like terms together. So I end up with that. So 5x plus 9 equals 19. Now doing the algebra, I need to get into this x, so I need to take the 9 from both sides. 5x equals 10, and then dividing by the 5, I know that x equals 2. Now what that means is somehow our two lines up here, these two lines are intersecting. The point where they intersect somehow, now if I just draw up two lines somewhere like this, and I'm not by any means taking account too much of what the lines look like, but I know that this point here is on the x-axis 2. What I need to find now is what is this y value here? What's the y value of our coordinate? To do that, what I'm going to do is substitute this value of x that we've just found, substitute x equals 2, and I'm going to put it into one of these two equations. It doesn't matter which one you do, but just make your life as easy as possible. This first equation is the simplest equation, so I'm going to put it into equation 1. So equation 1 says that y equals x plus 3, but we know that x is 2. So I'm going to have 2 plus 3, y equals 5. So my solution, my point where these two lines meet is at 2 on the x and 5 on the y. So this point over here would now be 2, 5. That's where our lines meet. Let's say, for example, and that's all you would need to do, but what about if you had decided to substitute this x equals 2 into equation 2 instead of equation 1. I'm just going to show you that you would still get the answer. So equation 2 says 2x, so I'd have 2 and my value of x is 2, plus 3y is 19, 4 plus 3y is 19, take my 4, 3y is 15, dividing by the 3, y is 5. So I would still get the same answer, but you can see it's a lot more work. This bit here is a lot more work than this bit up here. Still gets there, but it's more work. Let's have a look at another example. Solve the pair of simultaneous equations using substitution. Solve means find the coordinate. Okay. Substitution means put one of these equations into the other. So let's go through our naming protocol. This time my equation 2 has got an x equals something. So I'm going to substitute equation 2 into equation 1. So everywhere in equation 1 where I see an x, I'm going to write what x equals. So 3 times 4y, take 10, plus y is 9. So just reiterating that, in that first equation I had an x. The second equation told me that x equaled 4y minus 10. So I've just replaced one with the other. Now expand your brackets. So I have 12y minus 30 plus y is 9. 12y plus 1y is 13. Y minus 30 is 9. Then I'm going to add my 30 to both sides. 13y is 39. Divide by my 13. Y equals 3. So I have one part of my coordinates. So somewhere my graphs are intersecting and it's at y equals 3. I now need to know the x value. So is my point here or is it over here? I need to know the x value of my coordinate. So I substitute y equals 3 into one of these equations. I can do equation 1 or I can do equation 2. Equation 2 is probably the simpler one. They will both work, but equation 2 would be simpler. So let's put it into equation 2. So x is 4 lots of y, and we know that y is 3. Take 10. X is 12. Take 10. X is 2. So my coordinate where my two lines meet is x is 2, y is 3. I don't have to go through the process of graphing them, but if I did, they would meet at that point.